Hello friends, let's solve this example in which 3-methyl 1-phenyl 5-pyrazolone reacts with DMF plus POCl3 in excess. So we know that this is the identity of Vilsmeier-Haack reaction. This gives A compound and this A compound reacts with alpha haloester in presence of base. So also we know that this is the identity of Darzen condensation reaction. It gives product B. So let's solve this reaction with mechanism in which we know that Vilsmeier-Haack reaction occurs in two steps. First step is formation of formulating agent or Vilsmeier reagent. We know that in first step DMF plus POCl3 reacts with each other. Dimethyl formamide contains nitrogen has lone pair and it's converted into double bond, and this pi bond shifted over oxygen and its attack on phosphorus oxychloride's phosphorus. So chlorine leaves as a Cl minus. In next step we get this type of moiety in which nitrogen contains positive charge, so it's withdraw the electron from this pi bond, as well as this Cl minus attacks on this carbon. So we get this type of moiety in which nitrogen has lone pair. So this lone pair converts into double bond and this carbon oxygen bond shifted toward oxygen and phosphorus bond. So we get this type of our Vilsmeier reagent in which nitrogen contains positive charge. This reagent is also known as formulating agent, and nitrogen contains positive charge, so it's behave like electrophile. In next step, this is the step 2. This ketoenol tautomerization. We know that 3-methyl 1-phenyl 5-pyrazolone, it's in keto form. This hydrogen remove as H plus and this bond converts into double bond, and this oxygen consume negative charge, and this oxygen negative charge abstract this H plus. So this is the enol form. In this enol form, this double bond attacks on this carbon of Vilsmeier reagent, and this pi bond shifted on oxygen as a lone pair. So we get this type of moiety in which further this hydrogen remove as H plus and its bond electron converts into double bond, and this oxygen negative charge further attacks on this H plus, it's contain positive charge. So we get this type of moiety in which nitrogen has lone pair, it's converts into double bond, as well as chlorine leaves as a Cl minus. So we get this type of moiety in which nitrogen has positive charge, so it's withdraw this electron from pi bond, and as well as this double bond shifted toward this bond, and oxygen connected hydrogen remove as H plus. So we get this type of moiety in which nitrogen has lone pair, as well as we know that there is POCl3 is in excess media. So no, lone pair of nitrogen converts into double bond, and these double bonds shifted toward oxygen negative charge, and this negative charge oxygen further attacks on phosphorus oxychloride's phosphorus. So there is the as well as first step, so there is the Cl minus remove as the Cl minus. So we get this type of moiety in which nitrogen contains positive charge, so it's withdraw the electron from this pi bond, as well as this Cl minus attacks on this carbon. So we get this type of moiety in which nitrogen has lone pair, so it's converts into double bond, as well as these carbon oxygen bonds shifted toward the oxygen and phosphorus, so it's live as a living group. So we get this type of moiety in which nitrogen has lone pair, so it's convert into double bond, this double bond converts into this double bond, and this positive charge nitrogen withdraw this electron from this pi bond. So we get this type of moiety upon hydrolysis. This H2O oxygen contains lone pair, attacks on this carbon. Also this this positively charged nitrogen withdraw this electron from this pi bond, as well as this oxygen attacks on this carbon. So we get this type of moiety in which oxygen contains positive charge, so this hydrogen remove as H plus, and this bond oxygen, as well as nitrogen has lone pair, so it's abstract this H plus, this nitrogen abstracts this H plus. So we get this type of moiety in which nitrogen contains positive charge, So it's withdraw this electron from carbon nitrogen bond and leave as a leaving group. So there is the removal of H plus and this bonded electron converts into double bond. So finally we get our A product, in which we introduce this formyl group as well as this Cl. This Cl is because of excess POCl3. We know that in another step there is given of alpha haloester and sodium ethoxide. It is base. In presence of base alpha haloester, we know that this is the identity of Darzen condensation reaction. So first this alpha haloester reacts with this base and sodium ethoxide reacts with this acidic proton. It gets acidic proton and this bonded electron converts into negative charge of this alpha carbon. So there is carbon anion. It further attacks on these compounds carbonyl carbon. So we get this alpha carbon negative charge attacks on this carbonyl carbon. So this double bond shifted towards the oxygen. It's contain negative charge. So we get this type of moiety in which alpha carbon has Cl group and H, and this negative charge oxygen further attacks on this alpha carbon. So chlorine leave as a leaving group. So we get this type of alpha beta epoxy ester, which is our final product as a B of Darzen condensation reaction. Thank you.